So let's discuss collisions. Now, what is a collision? Suppose there is a ball here which is going in this direction, and you have another ball here which is going in the opposite direction, and their line of path is the same. Then there will be some interaction. After some time, what will happen is this ball will come and meet with this ball, and then there will be a internal force between them. Internal force will come into play between them, and that would change the momentum of each of them. But suppose I put them in a box, there is no change in the momentum. I mean, there is no external forces acting on the body. Because there is no external force, there is no change in total momentum. No external force acts on the body, hence there is no change in momentum as far as the system is concerned. But there is an internal force, and that internal force comes into play at the time of interaction between the two bodies. This will change the momentum of each body. Okay, so the momentum of each body may change, but overall there will be no change in momentum. That is, momentum is conserved. Why? Because there is no external force acting on the body. So suppose the first ball was moving, had a mass m1 and it was moving with a velocity u1, and the second ball had a mass m2 and it was moving with a velocity u2. This is the initial momentum. Then this is the initial situation. Then the initial momentum of the two bodies can be written as m1 u1 plus m2 u2. So this is the initial momentum of the two bodies. Suppose after the collision, again this one is moving with the velocity v1 and the other one is moving with the velocity v2. Then the momentum after collision will become m2 v2 plus m1 v1. Okay, so this is the initial momentum of the system. This is the final momentum of the system. Then the law of conservation of momentum tells us that the initial momentum is equal to the final momentum. That is, m1 u1 plus m2 u2 will become equal to m1 v1 plus m2 v2. Okay, this is what is the conservation law. Why can I write this? Because there is no external force acting on it. Now suppose there is a case where energy is also conserved, then the initial energy is equal to the final energy. So the initial energy can be written as half m1 u1 squared plus half m2 u2 squared, and the final energy can be written as half m1 v1 squared plus half m2 v2 squared. So once I write this, now I have two nice equations with me. This I can call it as equation 1, equation 2. How did equation 1 come? Equation 1 came by conservation of momentum, that is delta p is 0. Equation 2 came from the fact that conservation of energy, that is delta E is 0, but this is true only when there is an elastic collision. So we have collisions which can be defined as of two kinds. I can say that there is something called as an elastic collision and I have something called as an inelastic collision. Okay, in an elastic collision both energy and momentum is conserved, while in an inelastic collision only momentum is conserved, energy is not conserved. Okay, so we will work with this a little later. First let us work with this. Now if we want to solve these two situations, I will take all the m1s onto one side. So I will have m1 u1 minus v1 is equal to m2 into v2 minus u2. Here also I will do the same. So I will have half m1 u1 squared minus v1 squared is equal to half m2 into v2 squared minus u2 squared. Okay, so now this is 1, this is 2. I will just divide these two. So when I divide these two, first thing is the half here gets cancelled. Then when I divide them, m1 m1 and m2 m2 will get cancelled, and this is a squared minus b squared, that can be written as a plus b into a minus b. This is also a squared minus b squared, which can be written as a plus b into a minus b. So from here I will have 1 by u1 plus v1 is equal to 1 by V2 plus U2. Now I'll just do some small rearrangement there. So I'll just rewrite it. I have 1 by U1 plus V1 is equal to 1 by U2 plus V2. So on small rearrangement I'll get U2 plus V2 is equal to U1 plus V1, which on some more rearrangement will give me V1 minus V2 is equal to U2 minus U1. Okay. In other words, I can say that V1 minus V2 by U1 minus U2 with a negative sign is a constant. In this case it is equal to minus 1. This is what is called as your coefficient of restitution. Coefficient of restitution. Coefficient of restitution is a positive number and it is equal to the negative of the ratio. This is the relative velocity after collision, this is the relative velocity before collision. Remember that if we have VA and if we have VB, two bodies which are moving, the relative velocity of A with respect to B is VA minus VB. Relative velocity of B with respect to A is VB minus VA. This is how the relative velocity is defined. We learned this when we were doing vector quantities. So this is the coefficient of restitution. Coefficient of restitution is nothing but the relative velocity after collision divided by the relative velocity before collision. This is after collision, this is before collision. Now a collision is said to be elastic or rather perfectly elastic when coefficient of restitution is equal to 1. Now in case of an inelastic collision, the two masses stick together after the collision. In case of an inelastic collision, the two masses stick together after collision. If they stick together after collision, what is the relative velocity after collision? 0, because they are moving together. So if they are moving together and the relative velocity is 0, I can say that E also is 0. So now I can define an elastic collision and an inelastic collision based on the coefficient of restitution. Coefficient of restitution E is equal to 1 for a perfectly elastic collision, and the coefficient of restitution E is equal to 0 for a perfectly inelastic collision. This is how theoretically you work with it. Now whenever you get a question based on this, understand that whenever there is an inelastic collision, you conserve momentum first, energy is not conserved. Whenever you whenever you have a perfectly elastic collision, you conserve momentum and you conserve energy. Okay, so this is how you work with collisions. Now next I will explain to you how to work with each of them specifically. So once you understand this, we will move on.